Now we're going to work with what if f of x, our function, and we want to make it equal to another function, and we'll call that g of x. So let's say f of x equals x squared minus 5x, and our other function g of x equals negative 2x plus 4. Well, that's not too bad. We just got to set one, f of x, set it equal to the other one. We now have a quadratic in the making, so we just got to move everything to one side. This becomes x squared minus 3x minus 4. Factor now to find the zeros. 2 factors of 4, that makes 3. We want our 4 to be negative because the 3 is negative, and our 1 to be positive. So our answers are -4 and -1. Okay, next, let's talk about domain. As we have talked before, remember our domain is all the values that x can be. So all the x values. So let's see here. We are given f of x equals 5x squared plus 2x minus 1. Well, if we did a quick sketch of what that is a parabola, and it's going up. But what I know is that probably look a little bit something like this. We don't have to be completely accurate, but I know all the x values because we can have any value of x's going either way. That tells me our domain is all real numbers. So here, domain x can be all real numbers, like so, and this is from our set. Another way to write domain saying all real numbers, domain can go from -infinity to +infinity. So this is our set, and this is our interval, but both answers are pretty much saying the same thing. From -infinity to +infinity, x can have a value. Let's try another function and talk about domain in that function. Let's say h of t, our function h of t equals 4 over t. As we know, t cannot equal 0 because we cannot divide anything by 0. So our domain here is that t can be all real numbers. However, t cannot equal 0. Another way to write this is that from -infinity to 0, t can equal. And from 0 to +infinity. Okay, so another example, going down, oops, a little bit. Let's move over here. Let's say another function now instead of t, let's say y. Let's say g of y equals the square root of y minus 10 over y plus 2. we know from the y plus 2, y cannot equal negative 2. That will make our denominator 0. However, we also know in radicals that we cannot have a negative radical. So with y is minus 10, if we set this up as an equation, y minus 10, we know it has to be greater than or equal to 0. So y also then has to be greater than or equal to 10. And since those two rules apply, we know that y has to be greater than or equal to 0, but y cannot be negative 2. This y is greater than not equal 0 trumps y does not equal negative 2 because it is always going to be greater than negative 2 regardless, because 10 is larger than negative 2. So we can just ignore this one because y is greater than or equal to 10 overrides the other one. So this, our domain is y is all real numbers. However, y has to be greater than or equal to 10. Another way to write that is if it's greater than or equal to, we need a bracket at the end. So we need 10, comma, positive infinity.